Welcome to Summarize Science, where we dive into the latest breakthroughs in technology. Have you ever noticed how robots often feel stiff or awkward when they try to interact with people? Usually, their movements are either pre-programmed or require a human to manually correct them every step of the way. A new study is changing that by giving robots what the researchers call an inner critic. This system is known as CRISP, which stands for Critique and Replan for Interactive Social Presence. Instead of relying on humans, the robot uses a vision language model to watch itself and judge its own performance. It starts by analyzing its own physical structure, looking at its joints and how much they can move. The researchers created a way for the robot to understand its own body just by reading a configuration file. Next, the robot generates a plan for a social situation, like waving back when someone greets it. Because the system isn't tied to a specific type of robot, it works on everything from humanoids to simple rolling arms. The inner critic part comes in when the robot simulates its movement and records the results. The AI then looks at these images and asks if the movement looks natural and socially appropriate. If the wave looks too robotic or the timing is off, the critic pinpoints exactly which step was the problem. The robot then goes into a cycle of generating, evaluating, and regenerating until the motion is perfected. It's almost like a dancer practicing in front of a mirror, refining every gesture until it feels right. In one example, if a person dances joyfully, the robot learns to respond by clapping and cheering in a way that fits the mood. The researchers tested this on 5 different robot platforms to see how well it would generalize. They included advanced humanoids like the Unitree G1 and even a cute duck-shaped robot. Participants in a user study rated the CRISP-generated behaviors much higher than older methods. People found the movements easier to understand, more appropriate for the situation, and much more likable. This is a huge step forward because it allows robots to learn social nuances without a human having to label every single data point. The system can even handle complex, open-ended scenarios where someone might be sad or disappointed. However, the researchers noted that social interactions are subjective, so there isn't always one perfect answer. To wrap up, the most important takeaway is that robots are becoming more autonomous in how they learn social presence. By combining physical understanding with visual reasoning, they can move beyond rigid scripts. In the future, this could mean robots in our homes and workplaces that feel more like companions than machines. We might see an end to the uncanny valley effect where robot movements feel slightly off to our eyes. This research provides a foundation for robots to practice their social skills behind the scenes before they ever interact with a person. As these AI models get better at understanding time and motion, the interactions will only become smoother. Thank you for watching this breakdown of robot social intelligence on Summarize Science.